Is Tzuyin from NTHU. So he will talk about the molecular gas kinematics in the host galaxy of non-repeating FRB and hints about 924. Please start.
Hello everyone, I'm Tzuyin from National Tsinghua University, and today I'm not going to talk about disk, star formation, or any high-redshift galaxies. I'm going to talk about FRBs, host galaxies. So I'm going to talk about the molecular gas kinematics in one of the non-repeating FRBs, 18194B's host galaxies. And before I started the talk, I want to thank the 2022 CAT Summer School to support this research. And this is my outline today. I will introduce what are fast radio bursts first, and then I will talk about the motivation of studying molecular gas in FRB host, and then I will talk about the results, discussion, and conclusions in my papers. And last, I will talk about the future plan of studying molecular gas kinematics. So, what are FRBs? Fast radio bursts. Fast radio bursts are millisecond duration radio transient with its brightness to jump speed level, and they are generally come from cosmological distance. And they can be classified into two types. One is non-repeating FRBs, which doesn't repeat. Another is repeating FRBs, which has repeat burst. And actually, they are estimated that there are more than 1,000 FRBs on the sky every day. However, we have never known its origin. So the problem is that we don't know the origin of FRBs. So the first thing people would do is to constrain its physical environments of the host galaxies. And they will do many optical observations to the host galaxies too. However, in this plot, we can see that both non-repeating FRBs and repeating FRBs could be either star-forming or quiescent galaxies. And it also shows diverse properties in their host galaxies. So this means that we don't have a conclusive answer in the optical data. So how can we get a hint of the origin of the FRBs? Okay, so the solutions, which is this work, is to map the molecular gas kinematics in one of the non-repeating FRB hosts with ALMA telescope, which is a sub-millimeter wavelength, and to provide another perspective of FRB hosts. So why are these molecular gas kinematics so important? Because they are the fuel of the star formation. And if we can understand this kinematics, it can allow us to investigate the physical process of the host galaxies, which like smooth rotation, merging, or infalling gas, and which may be a link to the origin of fast radio burst. And this is our target, the host galaxy of one of the non-repeating FRB, 18194B. It is a massive early type spiral galaxy with the redshift of 0.3216. And to investigate the molecular gas kinematics, we have to detect CO emission line first. And this is the moment zero line map. And we can see that in the large red circle here, which is the host galaxy region. And there is a very bright there, which means that there is significant detected the CO emission line. And this is also first CO emission line detected in the FRB host. And we can extract the CO spectrum from the previous plot. And the blue line is the observed data, and the black line is the Best-Fit Gaussian function. And we can see that there is two velocity components, which shows a symmetric velocity profile. And this may indicate that there is a disturbed gas inside the host galaxies. So to further test whether this spectrum is really asymmetric or the gas is really disturbing the host galaxy, we have to apply a symmetry parameter, APIC. APIC is the peak ratio of the two velocity components. And so the higher the APIC value is, the more asymmetric the spectrum is, and may indicate there is a disturbed gas in the host galaxy too. And we compare our APIC value with the two H1 spectrum in the repeater's host, and which shows asymmetric in the H1 spectrum, and two gamma ray burst host H1 spectrum, which shows not asymmetric. So we can see that APIC value of our target is very higher than the two asymmetric H1 spectrums repeaters H1 spectrum. So which means that there is this means that the spectrum is highly asymmetric, and also there is a disturbed kind of structure of molecular gas in the host galaxy. And we also plot the velocity structure of the host galaxies, and we can see that there is a smooth velocity gradient range from negative 180 to 8 km per second. And we can see that there is no symmetric positive velocity components, and which shows a symmetric velocity gradient. And this may also indicate that there is a disturbed kind of structure of molecular gas in the host galaxy of FRBs. And also we plot the spatial components of the spatial distribution of the velocity components in the CO spectrums. And we can see that the positions of the two components is different, and there are multiple spatial components there. So we can also indicate that there is a disturbed kind of structure of molecular gas in the host galaxy. So in summary, there is a symmetric CO spectrum and a symmetric velocity gradient, and also there is multiple spatial components in the moment zero run map. And we can infer that there is a disturbed kinetic structure of molecular gas in the host galaxy of one of the non-repeating FRB, 18104b. And we also compare our results with the H1 detection of the 3 repeating FRB hosts. These 3 repeating FRB hosts, repeating one. Our target is non-repeating one, these are repeating one. So how about the H1 gas kinematics? Do you think it's disturbed or smooth rotation? Okay, so for the first one, the FRB 180916b, you can see that there is a very clear negative velocity components and the positive velocity components. And there's a halo between them, and this is the FRB positions, which shows the merging systems. So there's also this H1 gas. And for another 2 FRBs in the right panel, there are symmetric H1 spectrums, and which also shows the disturbed kinetic structure of H1 gas. So these 3 repeating FRBs all shows disturbed H1 gas structures. So in our conclusion, the result is that we provide the first CO kinematics, and we found that there is disturbed molecular gas kinematics in one of the non-repeating FRB, 18104b. And also we found that in the previous paper there are 2 papers discussing about the disturbed H1 gas environments around the repeating FRB hosts, the 3 repeaters. And also we can further infer that maybe both non-repeating and repeating FRB hosts shows disturbed gas environments, and this may suggest a possible link between the gas kinematics and the FRB progenitors. And so you may think that the sample is so limited, and how can I compare these results? Yeah, that's true. So the thing we have to do is that we have to have more molecular gas observations with ALMA or more H1 observations with BOA or Green Bank telescope and so on. So to get a more statistical results, and yeah, and I'll leave the conclusion page here and take questions. Thank you very much.
Thank you very much. We'll take question, comment.
Thank you so much for your talk. And since you presented some velocity map measured from the CO data, and I guess you already performed a lot of 2 component fittings for each of spectrum. Is that calculated from one of the Gaussian compound on this spectrum, or it just derived from the whole spectrum?
The whole spectrum. Yeah.
Then is that shows some typical velocity for the strongest line? Do you think?
Yes, for the one of the negative 180 is at the strongest line, one of the first components there. Yeah. Thank you very much.
Any other question?
very naive question. How accurate can you pin down the location of the FRB, especially for the non-repeatable? This is one event. Then I'm wondering what is the accuracy, positional accuracy of the FRB source?
Okay, this one is the large red circle is the host galaxy.
Yes.
And the very small red circle is the FRB position. So it is very well localized there, or you can see the optical image like this. The very small black circle there is the host galaxy. Yeah.
So, okay. Then what are the possible mechanisms for the FRB? That some mechanisms should have been proposed. Then and what are the possible mechanisms of FRB, proposed mechanism, and also how it is related to the gas kinematics?
Yeah, that's a very important question. Yeah, we don't know the mechanism of FRB so far. Like, FRBs are mysterious, so we try to get the hints from any perspective. That's the reason why we try to do this. Yeah, thank you very much.
Any other question? Oh, Tzuyin.
Yeah, I think Naomi has my question. Follow a bit because the FRB looks like a localized, very small region, right? And we don't know the origin. And also this disturbed gas motion is from large scale, right? Much larger than